So next we can start looking at some parallel and perpendicular slopes of lines. Parallel slopes are typically pretty easy because they just have to have the same slope as the other line, especially if the equation is given in slope-intercept form like this one, like y equals negative 3x plus 5. The slope of a line parallel to it has to just have a slope equal to negative 3. The rest of the expression is kind of irrelevant. It could be like y is equal to negative 3x plus 4. It could be plus 7. It could be minus ice cream cone. It doesn't make any difference as long as that part there is the same and it's in slope-intercept form. It's pretty straightforward. Same thing for this one over here. The slope has to be negative 2 over 3. I mean, that's really simple. Same idea over here. The slope has to be minus 3. It's really simple. Where it gets a little bit different sometimes is when the expressions aren't in slope-intercept form, like this one right here. The slope isn't going to be 3 just because it's sitting in front of the x, because this one sitting here is 2y, not just y. So we want is it to be in like the y equals mx plus b type format. So what you have to do sometimes is rearrange it in order to find out what the slope actually is. So this is where your order of operations and solving for stuff algebraically can kick in, because we want to try and get this y all by itself. So the first thing we would do in this one is we would actually subtract 3x from both sides. So we would subtract 3x from both sides. That cancels. And you'd have 2y is equal to negative 4 take away 3x. Okay, but now we want to have the y all by itself. So we would need to divide by 2. But then if you divide that side by 2, you have to divide everything by 2. So something like this. And of course, this would cancel like this. And then y is going to be equal to negative 4 divided by 2 is negative 2, and this would be negative 3 over 2x, something like that. Now this is actually in slope-intercept form, just have to rearrange this. Some people would prefer to rearrange it as y is equal to negative 3 over 2x minus 2 in order to see the slope is negative 3 over 2 a little bit easier. So this is just a little, it's the same type of idea as up here. We just need to try and get it into that form first by rearranging things a little bit in order to get it the way that we want. Okay, so same thing for this one. It's not in slope-intercept form. So first thing I'm going to do is I'm going to subtract x from both sides. And if I subtract x from both sides, it's going to cancel out here. And this will be 2y is going to be equal to 4 minus x. Then I'd want to divide by 2. So divide by 2 on this side would cancel out. Divide by 2, divide by 2. And you've got y is equal to 4 divided by 2 is 2. Take away. And you can have as x over 2 or write it as negative 1/2 x. It doesn't make any difference. And your slope would then be minus 1/2 because that is what is sitting in front of the x when it's in this form. Okay, same idea for this one over here. We'd want to subtract 4x from both sides. So this is going to give you 5y is equal to minus 25, take away 4x. Then we'd have to divide by 5. So divide by 5 here, divide everything by 5. That cancels out. So that leaves me with y. Negative 25 over 5, that's just negative 5. And then negative 4/5 x. So in this case, the slope would be negative 4/5. So it's when it's in basic slope-intercept form, like the first couple questions, that's pretty straightforward. But then sometimes you just have to rearrange it to actually get the slope, and then you are able to figure out what the slope of any parallel line might actually be. Okay, so what about perpendicular slopes? Well, perpendicular slopes, remember watching the lesson video and stuff from the textbook and stuff like that, it's not exactly the most complicated thing, but all you have to do is you've got your slope and you want the perpendicular slope. You have to take the inverse of it and then make it negative. So basically you have to flip your slope and make it negative, and that'll be a perpendicular slope. So if your slope was originally 10, then the perpendicular slope would be 1 over 10, and it would be negative 1 over 10. Okay, so if we go to these questions over here, we got y is equal to 2x plus 5. A parallel slope would be 2. That's no big deal. But the perpendicular slope would be the reciprocal, or 1 over 2, and then make it negative. Okay, so same thing for number 8 over here. The slope is right now just negative 2. So I'd have to flip it. And some people will do it like this. They'll just do 1 over negative 2, but then you got to make it negative. And of course, these two negatives will actually cancel out, which means it would just be a slope of 1/2. So a line with the slope of negative 2 would be perpendicular to a slope of 1/2. Okay, if we go to this one over here, the slope is negative 1/2. We have to flip it over and switch the sign, make it negative. So we have negative 1 over 2. So you got to flip it. So that'd be 2 over 1. It was negative, now it's going to be positive. So the slope would be 2. Okay, so just flip it over and change the sign. Over here, this is what we had like before, where it's not in perfect slope-intercept form. So just got to move things around a little bit, practice our algebra a little bit, and move things around. So we will subtract 3x from both sides. That cancels. We'd have negative 4y equals 8, take away 3x. Then we got to divide by negative 4. So we will divide by negative 4, cancels, divide by negative 4, divide by negative 4. And once we've actually got to this point, we can actually just sort of take it easy, because now we know what's in front of the x. This is what's in front of the x right there. It's negative 3 over negative 4, which will cancel out, and that'll be 3 over 4. So this right here will be 3 over 4. So to find that perpendicular slope, flip it. So 4 over 3. These guys were positive, now they'd be negative. So it'd be negative 4 over 3 would be the perpendicular slope to that line. Again, when it's in slope-intercept form, that's pretty easy. Sometimes you just got to solve for it a little bit and find out what the possible answers could be as well. Okay, if we do something similar for the next one, again, we'll do a little solving first, practice our algebra a little bit. We will subtract 7x from both sides. So we'd be left with 5y is equal to negative 15, take away 7x. Okay, and then what we need to do is divide by 5 all the way across. So we divide by 5, cancels, divide by 5, divide by 5. And right there, what I have so far, I can see that my slope for this one is going to be negative 7 over 5. So negative 7 over 5 is the slope for this one. So the perpendicular slope, I'd flip it. So 5 over 7 and change the sign. So it was negative, and so now it would be positive. So the perpendicular slope would be 5 over 7. And if we look at the last one, we've got this. So we got to isolate things as well. So we will subtract 6x from both sides. So I'd be left with negative 5y is equal to 15 take away 6x by subtracting 6x from both sides. Now I got to do the division. I got to divide by negative 5, divide by negative 5, divide by negative 5. Those guys cancel out. And just again, looking at what I have in front of the x, I've got negative 6 over negative 5. The negatives will cancel, so that would be 6 over 5. So I have to flip it. So that'll be 5 over 6. This was positive, so now it would be negative. So the perpendicular slope would be negative 5 over 6. So again, once the slope-intercept form, that's the basic way that we start, and that's pretty simple. But sometimes you can practice a little algebra and do questions like this as well. Just isolate the y as best you can, find out what's sitting in front of the x, just flip it, change the sign, and you've got the perpendicular slope.